Okay, stats. Multiplication rule with dependent events. Two events are dependent if the first one does have an effect on the probability of the other. Their example is picking two cards out of a deck without replacing the cards. I would say something like this. If event 1 was failing the first test, and event 2 was failing the class as a whole, does failing the first test change your chances of failing the class as a whole? I think we would all agree yes. So the general rule for the multiplication rule or formula is with dependent events, the probability of E and F, so that would be the probability of failing the class and failing the test, is the probability of failing the test times the probability of failing the class given that you failed the test. And we'll look at this. The multiplication rule problems still always are more than one selection. So you have 20 boxes of, or a box of 20 chocolates, 5 chocolate covered cherries. If you pick 2 chocolates out of the box, what is the probability you pick 2 chocolate covered cherries? So this often has to do with not replacing something when you're pulling something out of a hole. So the chances of picking a chocolate covered cherry first is 5 out of 20. But once one of those is gone, there are only 4 more chocolate covered cherries left, and we also removed a chocolate the first time. So notice that the second one, the odds change from the first one. That picking a chocolate covered cherry first changed your chances of getting a chocolate covered cherry second. This ends up being 1 over 19 because 5 times 4 is 20, so the 20s will cancel. So this is what they're talking about, where the odds change depending on what's happening. This is a 0.053. This is really an equal sign, it's exact. You won a free trip to Spain and get to take 2 people with you. You have 10 friends that want to go. 3 of them speak fluent Spanish. Put their names in a hat and pick 2 names. What is the probability of picking 2 Spanish speakers? So out of your 10 friends, 3 of them speak Spanish. So the first person out of the hat, there are 3 chances out of 10. But once a person has been picked, if you have to pick a Spanish-speaking person, because you need 2 of them, there are only 2 left out of 9, which is 6 out of 90, or 1 out of 15, 0.067. Now we can extend the rule to more than just 2 picks. What if you pick 3? Well, that's 3 out of 10 times 2 out of 9. If you want to get all the Spanish speakers, times 1 out of 8. This is now 6 out of 720, or 1 out of 120. This is going to be a small number, 0.008, if you're rounding to 3 decimals. So this differs from the conditional, but it does still use the idea of the conditional. But we may not go about it the same way that you do the conditional. Last page for these notes. You buy a CD that has 13 songs on it. You like 5 of the songs. With the random feature on your CD player, each song is played once in a random order. Find the probability the first 2 songs are picked. Now, newsflash, we don't really use CDs anymore, and if you only like 5 of the songs on most things, your phone, MP3 players, anything, you just put those 5 songs and other ones you like on. But I digress. Imagine you still had a CD player. What are the chances 2 songs you like? Well, 5 out of 13 you like. Once 1 has been played, it can't be played again, so that's only 4 out of 12 left. This is 20 out of 1. It's like 56, which can be reduced by 4 to 5 out of 39. What about 2 songs you don't like? Well, if you like 5, you don't like 8. But same strategy. This is 56 out of 156, or 14 out of 39. Now, the rest of the situations should be 1 song you like and 1 song you don't. You know, everything should add up to 1, so you should be able to do 1 minus the other 2 to get this. which is 39 out of 39, which is 20 out of 39. Now note, you don't have to do this with subtraction. However, if you're not going to do this with subtraction, you have to understand that there's two ways to do this. I could either go a song I like and then a song I dislike, or I could go the one I dislike first. You have to account for both of these if you're going to not use subtraction. So what are your chances of liking a song? 5 out of 13. Once that song is gone, how many songs you don't like are left? There's still 8 because you didn't hear one over 12, so that would be 40 out of 156. Otherwise, it's 8 out of 13 and 5 out of 12 if we go dislike then like, so another 40 out of 156, and you have to add them together to get the 80 out of 156 over 20 out of 39. So there's two ways to get the same problem. We'll talk more about a way around having to do this in the next section. 3 people are randomly selected, 1 at a time, from 5 freshmen, 2 sophomore, and 4 juniors. Find the probability the first 2 people selected are freshmen and the third is a junior. So there are 11 total. First 2 people are freshmen, so the first person's a freshman is 5 out of 11. That's 1 less freshman now and 1 less person, 4 out of 10. And so the third person's a junior. There were originally 4 juniors. There are still 4 juniors because we haven't picked one yet. So it's still 4 out of 9 because there's still 4 juniors. This is, looks like 2080 out of 990 or 8 out of 99. 0.0808, repeating over and over. And that is all for this section. And for, what is this? 5-5 rolls on next.